You can think of dy over dx as a small change in y over a small change in x. We know this is the rate of change of y with respect to x, and we can write that as dy over dx. So we're used to seeing this as gradient, but that's also the rate of change. If we replace x and y with variables that represent real-life quantities, we can use the derivative to represent lots of real-life situations involving rates of change, and this is a very important topic in your A-level. For example, if we look at this water butt, the volume of water is constantly changing over time. If the letter V represents the volume of water in the butt in litres and T represents the time in seconds, then we can model this as a function V equals f of t. So volume is a function of time. So dv over dt, which is the same as f dash of t, would represent the rate of change of the volume with respect to time. The units would be litres per second. So volume is measured in litres, time is measured in seconds, so litres per second. You'll see this a lot in mechanics. So for example, the gradient of a distance time graph is a measure of the rate of change of distance with respect to time, which is also known as velocity. So v, velocity, is equal to dr over dt. The rate of change of velocity is called the acceleration. So acceleration, a, is equal to dv over dt. The rate of change of velocity over time. So if we look at the first example, for part A, we're asked to find the velocity, which is the rate of change of distance with respect to time. So we need to differentiate our function for distance. Doing this gives us our velocity. So velocity is equal to dr over dt, which is equal to, so if we look at our function, t cubed plus 2t squared plus t, we differentiate with times by the power and take 1 off the power. So we get 3t squared plus 4t plus 1 as t differentiates to 1. So then for part B, we're going to use the fact that acceleration is the rate of change of velocity with respect to time. So if we differentiate the previous answer, but we can also write this as d squared r over dt squared, so the second derivative of our original function. So acceleration is equal to 6t plus 4. So for part A, we're asked to find the rate at which the object is climbing, so the rate at which its height is changing. So we differentiate our function of h with respect to t, so dh over dt is equal to 30 minus 10t. For part B, we're asked to work out when the object is rising and when it's falling. If the object is rising, then dh over dt, the rate at which its height is changing, would be increasing, so greater than 0, and when it's falling, dh over dt would be less than 0. So for bi, we get dh over dt is greater than 0, so 30 minus 10t is greater than 0, 30 is greater than 10t, and t is less than 3. And for part ii, we do the same, but dh over dt the rate at which the height is changing is now less than 0. So 30 minus 10t is less than 0. 30 is less than 10t. T is greater than 3. For part C, we're asked about its maximum height. Its maximum height is at a stationary point, so when dh over dt is equal to 0, which gives us 30 minus 10t is equal to 0. 30 is equal to 10t, and t is equal to 3 meters per second. So if we look at our next example, it's helpful to draw a picture. So we've got a piece of rope of length 120 meters, and we're asked to draw a rectangle. But we don't know the length of the sides. So let's call this length x and this length y. Okay. And we know that in total we've got 120 meters length. So 120 meters is equal to the perimeter, which is 2x plus 2y. We can simplify this to get 60 is equal to x plus y. But we're asked to find the biggest area that can be enclosed by the rectangle. So as soon as we see the word biggest area, we know that we need to find the maximum area. So maximum is when dA, because it's our area, over either dx or dy as one of our variables is equal to 0. So we need an equation for our area to start off. So area is equal to the base times the height, so x, y. And we need this in terms of the variable we've chosen. It doesn't matter which you do, dx or dy, they'll give you the same answer. I've written dx, so I'm going to substitute my other equation in. So I'll rearrange it first. So y is equal to 60 minus x. As I'm trying to get rid of y, I'm going to substitute that in. So my area, A, is equal to x times by 60 minus x. So all I've done is I've replaced y by 60 minus x. I now need to differentiate my function of area with respect to x, but before I can do that, I need to expand the brackets. So area is equal to 60x minus x squared. And now I can differentiate that function with respect to x. So dA over dx is equal to 60 minus 2x. And I know, because it's a maximum, that that is equal to 0. So dA over dx is equal to 0. So 0 equals 60 minus 2x, which I can then rearrange to find x. So 2x equals 60 and x equals 30. However, I've not yet found the area. So the question wants the biggest area. All I found is x. So I now need to find y. So y is equal to 60 minus, I'm going to substitute my value of x, which is 30. So y is equal to 30, which gives me my final answer of the area is equal to 30 times 30, which is equal to 900 meters squared. So now I want you to complete page 286, exercise 12k from the textbook, question 3, question 5 and question 6. Make sure if you've got any problems you come and see one of the maths teachers before the homework is due.